As Maria introduced, I'm Jenny. I guess in the context of Maria's fellowship as well as for AdSolve, I do a bit of work on evaluation. So both for synthetic data as well as for evaluating LLM, sometimes using synthetic data. So a quick overview of the presentation. I'll be talking at quite a high level, but just to provide an overview of some of the tasks that we've been working with, some of the challenges that are shared between these different tasks, and then also some learnings that we have related to these projects. So first of all is work looking at synthetic data. Second is on the mental health summarization work, which Jia has presented earlier, but focusing a bit more again on the evaluation challenges. And third is using data to evaluate LLMs and specifically focusing on privacy preservation in a setting of ambient clinical documentation. So synthetic data. Why do we need to generate synthetic data in the first place when we have real data to work with? There are a few reasons for this. One is maybe there isn't that much real data that we could be using for our models and for our analysis. So in this case, it would be useful to perform augmentation. And sometimes you would also generate synthetic data for privacy preservation. You could also do augmentation and aim for privacy preservation at the same time. In essence, what we do when we generate synthetic data for privacy is we're trying to retain useful properties of the data while also removing identifiable information that can, I guess, like leak information about the original data subjects. And then finally, related to the privacy preservation in the clinic type project that I was talking about earlier, another emerging use of synthetic data is in benchmark construction. So in cases where it's difficult to collect a lot of, I guess, document label pairs or to have data that to perform the type of evaluation that you want, or to have test data for your software, let's say, by conditioning on some ground truth to generate data, you can then create documents that should contain some of these properties or information and therefore apply them for further testing. So in our paper, we developed an evaluation framework for synthetic user-generated content. At a high level, this is the framework presented in our paper. I won't go into too much detail, but essentially it operates under the premise that there's some data that we're interested in, and we want to generate from them for purposes including augmentation and privacy preservation. There might be some user identifiers, be it user IDs or some labels associated with the individuals, for instance, their demographic information. So here, if such information is available, we can run additional analyses on how privacy preserving the downstream data is. Then in addition, we also look at evaluation from two further perspectives. One is intrinsic evaluation, where we're essentially trying to assess how good is the data that we generated. And here we identify three aspects that are particularly relevant to the task of social media data sets and user-generated content, which are meaning preservation, style preservation, and divergence. But of course, these are also applicable to other domains as well. Then we are also interested in seeing how useful the generated data is. And so we use it in the paper to train classifiers, and then we assess the performance of those classifiers on a held out test set of real data. And so in the paper, we ran a series of experiments testing varied generation strategies and experimenting with representative data sets of varied complexity. Some of the strategies involve controlling for the style preservation. And what that does is it allows us to look at the impact of style on these data sets that involve, I guess, UGC and some notion of user tracking and monitoring over time. And as I mentioned, there are some extrinsic evaluation tasks that can be applied. From a privacy perspective, maybe we don't care as much about the augmentation, but we're really interested in making sure that users are not identifiable from the synthetic data. So in those cases, we, I guess, focus a bit more on the re-identification. And then we also look at different settings of augmentation where, from very limited amounts of data to cases where data is more readily available. And now I will go through some of the high-level results. So overall, we found that style preservation do seem to benefit task performance. In particular, we find that there's a a different effect for style similarity and style consistency. What I mean by consistency is, let's say we have, we call the timeline that, we have individuals talking about their mental health over time, posting on social media. And when we're generating synthetic data, if we have style consistency, that means the synthetic posts of the user will be consistent within the timeline itself. So, I speak a certain way. I would hope that synthetic data of a synthetic Jenny would also write in a consistent way as I post about my life over long durations. So we find that that has a benefit, and it also has a benefit that is different, or I guess like somewhat complementary to just having naive style similarity. We also find that the higher the divergence of the data and the lower the style preservation, the more privacy preserving it is. But that is only the case for some more simple tasks of privacy in terms of reducing the amount of user profiling. So for instance, predicting the gender of the individual based on their linguistic content. When it comes to more when it comes to privacy from the perspective of re-identification, so not only looking at the demographic label, but actually looking at linking back to the individual themselves, we find that actually a lot of the existing methods that have been proposed for privacy preservation fail to prevent re-identification, suggesting that this is open work, an open problem. And so these are the main takeaways. Again, we find that style, which is underexplored in a lot of tasks in NLP, actually do seem to impact task performance, and specifically on some of these tasks where there's it requires personalized modeling and user tracking over time. And we also see that, again, a lot of the methods are insufficient for meaningfully preventing re-identification. We do find that differential privacy is effective, but it is at the cost of reduced performance. Okay, so now on to summarization work from social media and mental health. And this is related to several topics. One is the project that Jiayu has described earlier, and the other two are related to previous CL Psych and a CL Psych shared task that is currently ongoing. So here's a list of them. To be a bit more specific, I will now go into the different tasks. So for the CL Psych 2024 shared task, the task is to identify evidence. So you see the highlighted spans here, text spans that support a prediction of suicide risk level. And in addition to that, the task is also to synthesize the evidence into a prose, into a summary that describes how these supporting evidence, be it risk factors or protective factors, contribute to the prediction of the suicide risk. Similarly, in this year, we have a related, but in some ways slightly more complex problem. So here, well, the text is fake, but the task is relatively similar to the earlier one. So here, instead of just having one category of evidence, we have two categories of evidence, which is looking at adaptive and maladaptive self-states. And in addition to evidence extraction, we have post-level summaries, again, synthesizing the different types of evidence and how they relate, what they say about the individual's mental health. And finally, a timeline level summary that not only looks at the individual content of the post, but also look at the dynamics of the self-state over time within this chronologically ordered sequence of posts. Then the third project is the timeline summarization from social media one. Again, Jiayu has already presented this, so I won't go into too much detail. But from an evaluation perspective, some of the challenges are, first, because the timelines are quite long, we need to compress it into a, I guess like a more manageable length, where we can then, one, present it to potential, let's say, clinicians or the patients themselves, so that it's easier to digest quickly. And two, then, is to create a version of it that presents more mental health related information. And so these are some of the criteria that we summarize around. And in essence, what we get is something like this, where we have two views of the same data stream. So one is a compressed version of the timeline. The other is a high-level summary that contains the mental health related insights. So now moving on to the evaluation challenges. Obviously, evaluation is there's a lot of research work in this area. So evaluation for mental health summarization shares some of the challenges with general domain generation, which includes, we want to make sure we catch and penalize hallucinations, potential biases. But there are also some additional challenges that comes with modeling text and mental health and evaluating them. So for instance, the importance of capturing in-domain knowledge in cases where we have different views of this. Oh, thank you. Okay, so I will try to be a bit more concise. But in cases where, let's say we have two different views of this, of the same timeline, then we also need to look at whether or not the timeline summary supports the mental health summary. We need to assess them in relation to each other. And because the summaries are quite detailed, maybe it'll cover, say, mental states or intrapersonal relationship. So between these sections, we also need to assess whether or not there's internal consistency, so that it doesn't say, oh, Bob is suffering in the first sentence and then ends with something that completely contradicts it. So now on to the evaluation metrics. So these metrics are organized around different aspects, which are criteria where we think are particularly important for these types of generations. One is salient meaning preservation, which is essentially looking at whether or not the summary captures information, so highlighted phrases or key information that we expect it to capture. The other is around factual consistency. Again, wall of text, but the main thing to take away from the slide is the use of an NLI model. So what an NLI model is, it's a model that was trained on a task of, predicting the logical relationship between two pieces of text. So let's say the premise can entail the hypothesis, the premise can contradict the hypothesis, or maybe there isn't really much of a relationship between these two pieces of information. So by applying this model as like a module or a tool for evaluation, we can then use it to assess, for instance, whether or not the summary is faithful to the original document, or if, let's say, different parts of a summary is consistent with each other, or whether or not our summaries are consistent with what the experts have summarized. And so we also look at other aspects, including coherence and fluency. The main takeaway from this is NLI-based approaches are helpful for assessing logical relationships between source documents and model outputs, as well as comparing, the LLMs against experts, let's say. But there's still a lot of unsolved problems, including handling conflicting information, better incorporation of domain expert knowledge, and looking at how, let's say, different pieces of information relate to one another. So I have 2 minutes left. I will zoom through this. The third project that I'm talking about is related to using synthetic data to assess privacy preservation in clinical documentation. People are using LLMs for a lot of stuff, and this can be problematic. So including psychiatrists, there has been this uptake in co-pilots in the clinic, where essentially you have, let's say, an ASR system that transcribes the interaction. I go in, I talk to my clinician about my problems, and then the output of that session would be, let's say, notes or letters from the session. So sounds great, it's very convenient, helps reduce administrative burden, but you could see where some risks might come from this type of AI use. So this is the type of problem that I was looking at. Essentially, given this transcribed encounter and some output notes, how do we look at how privacy preserving these systems are? And this relates to this idea of contextual integrity and privacy, where essentially we're not just thinking of privacy in the sense of, okay, it's PII, therefore it's sensitive and it can't be shared. Because in a clinic, for instance, maybe I don't want my health information to be on social media, but if the information sharing context is that I'm in a clinic and I'm talking to my GP, then it's okay for the information to be shared. It's aligned with the information sharing expectations. And so this framework addresses privacy in a more, within the situation of information sharing. And so without going into too much detail, based on current benchmarks, it seems that the models are not very good at understanding what information is shareable, under which circumstances. And this happens even if you use very advanced models with privacy prompts with some sort of reflection. It's still not solving the problem. So here in this benchmark, what we do is we defined private information for this particular context as third-party personal information that is not directly relevant to the patient's care. And the way we create a benchmark is we modify an existing data set of clinical encounters with gold standard notes. This way we can see whether or not any mitigation strategies for privacy would affect note quality. We inject the information, generate notes, and see whether or not the notes contain private information. So here's an example of a private information that was injected that ends up in the note when it's not supposed to be there. And so we then benchmark different models, look at different types of privacy leakages, both specific and generic. And essentially what we found is basically all models leak private information. And we also find some effects of, let's say, specifying the note structure or differences between different model classes. But essentially, even though the leakage rate is slightly reduced, when we specify things like, okay, only include information that is directly relevant to the patient's care, it doesn't actually solve the issue. The leakages still persist. And so just to be a bit more concrete, we find examples of both generic information leakages that are relatively benign. So it's like, okay, patient discussed personal activities, including yoga and potential hiking. Not very relevant to their care, but it's included anyways. Whereas on the other side of the spectrum, somehow the note contains leaked information about the patient's cousin's Peter's mental health challenges and stigma surrounding anxiety medication, which is very specific and also, directly identifies the information subject. So we have leakages across the spectrum. And I guess finally, there is also this phenomenon of a knowing type of leakage, where it knows it's not supposed to include some information, but instead of ignoring that in the output, it says, well, this sensitive information is not relevant to the care, it's probably privacy infringing, so we won't include it. But having this disclaimer, just, it's not great. So this is in line with some concurrent work from other groups that look at probing models, and they find that even if models can answer, let's say in QA settings, about privacy norms, whether or not something is private, when they're used for actions in like an agent-like setting, they still reveal the information. So it highlights also a limitation of using QA type evaluation approaches. And then finally, slides are not completely visible, but essentially we looked at a generate then edit approach to see whether or not we can generate a note first and then edit away the private information. And we found that here, you have to be very specific in telling the model, so define privacy as information that's not relevant to the patient's care. If you just tell the model to, hey, make sure the note is privacy preserving, it doesn't really work, which is problematic because you can't exhaustively define what private means under all of the infinite, settings that you might use an LLM for. So the main takeaways, through our benchmark, we find that all examined models leak third-party personal information. Having awareness of information sensitivity and what is considered appropriate information flow doesn't actually remove the leakage. Using some privacy instructions helped, but it's not a robust or a complete solution. And so overall, it highlights the need to develop systems that are private by design rather than using post hoc mitigations like prompting. And possible directions include, for instance, models with greater contextual awareness and reasoning ability around privacy.
Thank you, Jenny. Other questions? Yes, Tom. We'll take a couple of questions. Because we're going to
get... Thanks, Jenny. As usual, really good. I just wanted to make a comment about using contextual integrity as the relevant concept. I think it's very good philosophically because it accommodates lots of different phenomena. But one of the things about contextual integrity is that it varies. It's very geared to conventions. So there are conventions related to different activities, including psychiatric exchanges and so on. And so it's much more, shall we say, general and lax than consent and other kinds of criteria. And contextual integrity was introduced to go against the general GDPR understanding, that privacy is control of information. That has many defects, the idea that privacy is control of information. And I think you need to make that explicit, perhaps, that by taking the Nissenbaum approach, she's the one who came up with this, you are kind of altering what most of the readers will take to be the terrain. But I agree with you, though.
Thank you. Yeah, just a point on this. I guess what it reminds me of is, privacy preservation is not just about information sharing. I think, how should I say this? So sometimes when we look at privacy preserving systems in NLP, there might be a conflation between, let's say, like information security versus, consent versus then contextual integrity. So I see them as more complementary rather than, we must choose one or the other. So definitely consent remains important, but you also need to take into account, even if there is consent, when it comes to information sharing or applications, how do we assess privacy preservation from that angle?
It'll vary from practice.
Thank you.
Thanks for a great presentation. You mentioned all examined models leaked third-party information. Are there variations with them, or are they all about the same amount?
Yes, so there are variations. Sad to say, the closed-sourced proprietary models tend to perform better in terms of privacy preservation, but we do see some differences in, for instance, whether or not a model is the model size. Also, we see a difference among proprietary models. So when it comes to Claude, the version that is more marketed for coding purposes tend to leak less private information. So we haven't exhaustively tested, if it's a causal relationship, but we do find that leaked fewer private information compared to the generalist model that is tailored for, I guess, a wider range of tasks.
Those models are better and less leakage.
In this particular setting.
Okay. I mean, it's certainly a major issue that patients relate their reluctance to have their private information shared, and of course, it gives rise to many medical legal consequences. Thank you.
Thank you.
So there was a question online, and then I think there was afterwards. But good. The person online, can you?
Yeah,
can you...
I will ask. Hi, Jenny. My questions is mainly because of my lack of experience in this particular area, but we do use LLM and chatbot a lot for workers, for migrant workers. So, for example, when you say violations, do you mean the LLM? Say, for example, accidentally you have your address disclosed in the LLM. Does it mean that me as a different person, somehow I can ask LLM, what is Jenny's address? Do you mean that? What do you mean by violation? Do you mean that someone else can find the private information?
So not in this case. There have been work looking at PII leakages and I guess more memorization in large language models. But in this particular setting, the violation would be, for instance, I go to my GP, I talk to them about my coworkers' health issues. So because their health issues is their personal information that is not related to why I'm at the GP, the notes for that session should not contain information about my coworkers' health.
So this is in the summary output. Yeah.
Yes.
Something like that. Okay. The other one I want to ask you is you mentioned the style is a very good way of detecting kind of person. So then my question is the reverse, in the sense that have you thought of any way to stop someone being detected because of their very peculiar style or conversation or asking question?
Yes. So we do find that there are two, I guess, parts to my answer to your question. One is we do look at techniques like back translation, which is has been explored in prior work related to privacy, and they found that it removes the identifiability from a demographic angle. So for instance, you're less likely to predict an author's, let's say, gender by the style and content they write compared to if you haven't transformed the text this way. But having said that, when we looked at re-identification, it actually wasn't very effective when we're looking at this like from a larger data set in a more real world setting. So I think there's room to explore this a bit further, but so my first answer is yes, it has been done, but it's not very effective. And then two, related to this, I think it ties into the potential trade-off between, let's say, style preservation and divergence. So yes, we can transform the text and generate new data in a way that might be useful for some application, but at some point you sort of reach a threshold where it's not really recognizable to be the original individual anymore. So it's a delicate balance between how much to keep and how much to vary.
Yeah. I think I got two other points that always bother me a lot, but I don't think it is fair to criticize anyone for not thinking about it. One
sorry, we'll have to move to the last question now because we're running late with the talk.
Sure. Yeah.
Thank you for your questions.
Thanks.
Sorry about that. Thanks for your time. Is this on? Yeah. Fascinating talk. It's really just to follow on from an earlier question around the context and the sort of around privacy and documentation. 2 points very quickly. One is, did you compare privacy leak in real life documentation in human professional documentation? And there is obviously, your finding is there is always a privacy leak. It's the variation of the degree. And what are we comparing against is what I was wondering as the first question. And the second is, I'm not sure I saw or in the slides, there are lots of softwares now offering sort of commercial AI ambient voice or HiD, or did you try sort of test them out? Or because I saw more mainstream AI tools in your talk. Thank you.
Thank you. So my answer to both of those are actually, I wish I had the data and access to the tools. For more practical constraints, this was work done while I was doing an internship at NHS England. So we were a bit constrained on time and what could be delivered through the project. And I guess another constraint is that we were more interested at the individual models rather than models that could then potentially be embedded into a system for further use. So yeah, would be great if we could catch, I guess, leakages in the wild, but then obviously getting access to the data and finding such problematic cases in real data would be a different challenge.
Okay, well, thank you very much, Jenny. We'll have to move now to Sebastian's talk. So I suggest for those of you who had questions for Jenny to grab her during